Good morning, students. So we have seen here, we have learnt that the intensity of the magnetic field produced by a current carrying conductor is directly proportional, means what? Equal, proportional to the amount of current flowing in the conductor. Okay, so that means the magnetic field is directly equal to the current flow in the conductor. How much? If electricity is flowing more, means magnetic field will be more. If the electricity is flowing less, means magnetic field will be less. Okay, so underline this point. So we have a wire coil of an n circular loops. So if the so much conductor is big, that means the wire that we are circling na, so this is called as a coil, loops. When the copper wire or any wire going like this in the circular shapes, so it is the coil. Okay, loops. So when we increase this one, the current flow will be increased and magnetic field also will be increased. Okay, so now repeat the above activity by reducing the diameter of the wire loop. The coil acts as the thin disc magnet, where one plane of the disc acts as a north pole and the other plane act as a pole of the magnet. So one will be acting as a south and another one will be acting as a north. South side always it will show the magnetic direction will show in the clockwise direction, and in the north side the flow of current will show in the anti-clockwise direction. Okay, so here magnetic field due to a solenoid. What is the solenoid? Okay, so solenoid is a cylindrical shaped tube formed by a tight coil. So this is the copper wire. Okay, so this one will be coil, that means like circular shape and round it is like this. Tight coils of conducting copper wires shows a solenoid whose two ends are joined to a battery. When current flows in the solenoid, a magnetic field is produced around the solenoid. Compare the pattern of the magnetic field in figure 9. The magnetic field shape are shown in the figure 4. Okay, so this is the solenoid. Solenoid means when the copper wire when it has the tight coils and to conduct the electricity and two ends are joined with the battery, so it is the solenoid. When the current started to flow, so it has its own magnetic field. Okay, so this magnetic field is like figure 4. In both the figures, the magnetic lines of force appear as similar shape and pattern, and thus the magnetic field produced by a solenoid is similar to that of the bar magnet. So bar magnet also magnetic field will be like this, it is coming na. So it is similar to the this one solenoid also. So and one end of act as a north pole, one end act as north pole, other end is acting as a south pole. Okay, so here we can see this now. Okay, so the magnetic lines of a force inside the solenoid are parallel lines. So inside the solenoid magnetic lines are parallel one, each lines are parallel to each other. So one line like this, another line is straight to this one, means it is the parallel. So parallel lines, and then which shows that magnetic field inside the solenoid is uniform. The magnetic field produced inside the solenoid can be used to produce a magnet by placing a piece of magnetic material like iron inside the solenoid. So inside the solenoid, inside this copper wire coil, when we keep the magnet inside of this, so it will act as a magnet. Okay, solenoid. Now you see this is the solenoid. Okay, so inside this is the bar magnet, insulated copper wire, soft iron core. This is the iron core. Okay, the original pure iron metal. Around this is called as a soft iron core. Okay, so around this some copper wire is rounded. Okay, so this is the south side, north side. South side will show clockwise current and north side will show anti-clockwise current. So clock means it will go like this, na? This is the one. Yes, like this. Anti-clockwise means like this it will go. Yes, so this is the one. So circular shape formed by bending conducting wire is called as a loop or coil. Underline this. What is the loop or coil means? When the copper wire is bending. Okay, so it is shape is bending, circular shape formed by bending. So the coil and where the current direction is clockwise act as a south pole, and the other end where the current direction is anti-clockwise act as a north pole. Okay, so this is the one. Imagine a circular loop or wire placed on a table. If a clockwise current is flowing on the loop, find the direction of the magnetic lines of force inside the loop and outside the loop. Okay, so inside the loop current flow will be in the magnetic lines direction will be in the clockwise. Which side? North, south side. North side it is the anti-clockwise. Okay, so anti-clockwise means clock in means gadi, na? Gadi it will go like this. Inside this one it will go like this, around like this it will go. But anti-clockwise from behind it will come. So this is the anti-clockwise.